Welcome to the channel Maths for Graduates. Today we will see some properties of gamma function. So let's start. First property is gamma n plus 1 is n times gamma n. Okay, and this relation is defined for n positive. Okay, now let's prove this property. So from the definition of gamma function we can write gamma n plus 1 is integration from 0 to infinity e raised to power minus x raised to power gamma n is x raised to power n minus 1. So here we have gamma n plus 1, so it will be x raised to power n plus 1 minus 1 dx. Okay, simply we can also write this as integration from 0 to infinity e raised to power minus x, and we can see here this 1 and minus 1 cancels out. So we have e raised to minus x raised to power n dx. Okay, now writing this integration as 0 to b, and b is, and this b is tending toward infinity. Okay, so we have e raised to power minus x raised to power n dx. Okay, now let's integrate this using integration by part. So using integration by part we can write this as limit b tends towards infinity, its integration will be first function integration of second function is e raised to minus x. So integration of e raised to power minus x will be e raised to power minus x over minus 1. Okay, and limit is from 0 to b. Okay, minus integration 0 to b, differentiation of first function. So differentiation of x raised to power n will be n x n minus 1 into integration of e raised to power minus x, it will be again e raised to minus x over minus 1 dx. Okay, so we have limit b tends towards 0 inside bracket. So let's put limit here. So after putting limit, it will be minus b raised to power n e raised to minus b and minus 0. When we put x equal to 0, it will be 0. So 0. Now we have plus this minus sign and this minus sign, make it positive. So we'll have here plus sign plus integration and taking this constant n outside. So we have here n e raised to minus x raised to power minus n minus 1 dx, and limits from 0 to b. Okay, now let's find limit. Okay, so when we put limit, this value e raised to power minus b goes to 0. Okay, when b tends to infinity, e raised to minus b will tend towards 0, this factor will be 0. So we'll have 0 plus n. So on putting limit, it will be 0 to infinity e raised to minus x raised to n minus 1 dx. Okay, and this is what this integral is, gamma n. Okay, so in left hand side we had gamma n plus 1, and in right hand side what we are left with? We are left with n times gamma n. Okay, and this is the required relation that we were looking for. Okay, all right. Now let's see what is the value of gamma 1. Gamma 1 will be, from the definition of gamma function, it will be 0 to infinity e raised to power minus x raised to power n minus 1. So x raised to 1 minus 1 dx. Okay, so simply we'll have integration 0 to infinity e raised to power minus x dx. Okay, so after integration we'll get what? 1. Okay, so gamma 1 is simply 1. Okay, now let's find what is gamma 2. Gamma 2 will be, from this relation, from this recurrence relation we can write this gamma 2 as 1 gamma 1, and gamma 1 is 1, so it will be 1. Okay, now gamma 3, again using that recurrence relation, we will have 2 gamma 2, okay, and gamma 2 is 1 gamma 1, so we will have 2 into 1, and gamma 4 will be 3 gamma 3, and this gamma 3 will be 2 gamma 2, and 3 2 gamma 2 will be 1 into gamma 1, so it will be 3 into 2 into 1, okay. Now we can see here that gamma 2 is 1, gamma 3 is what, factorial 2, and gamma 4 is factorial 3, okay. So using this relation we can generalize this as gamma n is factorial n minus 1, okay. So this is the another very important property of gamma function, relation between gamma function and factorial, okay. And one more thing which is also very important, the value of gamma 0 and gamma n when n is negative, okay. So gamma 0 will be infinity and gamma n will also be infinity, and here n is negative, okay. So these two values are also very important. Now this video ends here, and I have a quick announcement to make. Those students who are preparing for exams like CSR NET, GATE and other MSc entrance examination can buy our real analysis handwritten notes for a very reasonable price for only ₹80. So if you are interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.